Complex numbers is what we're going to be talking about today. And when people hear that, they automatically think, oh my gosh, this is going to be really tough. I will warn you, this is actually one of the easier, if not the easiest sections of this entire chapter. And so first of all, we're going to define what is known as the imaginary unit. And if you notice, the imaginary unit is symbolized with I. And notice it's kind of an italicized I. Basically, what I is defined to be. I is defined to be the square root of negative 1. You're probably wondering, what? Well, what ends up happening is, if you would get like the square root of negative 3, you can't take the square root of negative 3. Your calculator gives you an error. And so what they've done to counteract that is they've defined I to be the square root of negative 1. So I is how we write the square root of negative numbers. Now, if I were to square I, so take I times I end up getting negative 1. Now, for those of you wondering, how does that occur? Well, remember, if we multiply a square root times itself, it's basically like the square root doesn't exist. And so in this case, we just get negative 1. And a pure imaginary number is a number of the form bi. So basically, and right now that might not make a whole lot of sense, but we're going to define something known as a complex number shortly. And so anyway, a pure imaginary number, numbers of the form bi, so 6i, negative 2i. You could have root 3i, but it's just a number times I. That is what a pure imaginary number is called. And so what we're going to do is we're going to do some operations with imaginary numbers today. And as I said, it's not going to be difficult at all. Okay, and so if I look at this, simplify square root of negative 27. Now one of my rules always is you can never answer a negative square root. You always have to simplify it. And so we have to simplify this. So in order to simplify this, the very first thing we're going to do, we're going to get rid of that negative sign. And how we're going to get rid of that negative sign is we're just going to attach an I. So I'm going to have root 27 times I. Now you need to be careful that I does not go underneath the square root. I goes totally separate. So what some books will do, and some people will do, is they will write it this way. It's the same thing. But we're not quite done yet. Why aren't we quite done? Yeah, we can break down the 27. So remember, this is when we do a factor tree. And so I need to think of two numbers that when I multiply them, I get 27. What are those two? 9 and 3. And remember, I need to keep breaking these down till I get prime numbers at the very bottom. I can break 9 down to 3 and 3. I can't break 3 down. It's as low as it goes. And so if you remember, what do we take out?
The threes.
I take out pairs. So I see I've got a pair of 3 here, right? So that means I take one of those outside the square root. I still have a 3 left here, but it doesn't have a partner, so it can't leave.
I thought
It's got to
pairs
stay
were
put.
like up and down next to each other.
No. They're at the very bottom. Okay, and then notice I still have my I. So this would be an answer. You will see some people write this as 3i times root 3. Either of those is acceptable. It doesn't matter. Either of those is acceptable. It doesn't matter. All right, with that in mind, let's have you go ahead and work on this one for me. Okay, square root of negative 216. Okay, so, first of all, this is root 216 times I. What we're going to do now is break down 216. 216 you can break down to be 6 and 36. Okay, in which case you can break 6 down to 2 and 3, and 36 down to 6 and 6, and then 6 down to 2 and 3, and 6 down to 2 and 3. Now that's not the only way, but that is one way. And so then next I'm going to take pairs out. So I have a pair of 3s here. So I'm going to take a 3 out. I also have a pair of 2s. So that means you're going to take out a 2 and a 3, which means a 6 is going to be there. Inside the square root, you have a 2 and a 3, which is a 6. And so you get 6 root 6i, or you could write that as 6i root 6. Okay, so of negative 18. Let's go. Okay, so you should have broken 18 down. When you break 18 down, you should get 3i times root 2. Or you should get 3 root 2 times I. So that's what negative 18 breaks down to. So now what we're going to do is we're going to talk a little bit about what I is. Now first of all, we're going to write everything in terms of I. Now this is actually one of those that you're going to notice something. And so we know that 1i is just going to be I, or the square root of negative 1. Now what do you know I squared is equivalent to? I squared is equivalent to negative 1, right? That was what it was on the very first page. So now I need to think of I cubed. I cubed means I times I times I, right? I times I times I. I squared means I have how many i's? I squared means I have 2 i's, right? What do I know that I squared is the same as? Negative 1. So that means I can put negative 1 in place of this. So if I put negative 1 in place of that, I have negative 1i, right? What?
So if I up here equals the square,
we're doing things something totally different, okay? I know what you're going to say. If it equals the square root of negative 1, I know. We're writing this in terms of I. We're writing this in terms of I or 1, and you'll see a pattern that happens. Okay, so I to the 4th is going to be I times I times I times I, right? Okay, and so these 2 i's make what? Negative 1. These 2 i's make what? Negative 1. So I really have negative 1 times negative 1, which is 1. Now, what does I to the 5th equal? It equals I times I times I times I times I. Okay. I times I is what? Negative 1. I times I is what? Negative 1. So I end up having negative 1 times negative 1 times I, which is just what? 1i. I to the 6th. I times, oops, this is a different color. Okay, I to the 6th. I times I times I times I times I times I. So let's see what I'm going to have. Negative 1, negative 1, negative 1, which gives me what? Negative 1. So let's start looking for a pattern. Let's see. I, negative 1, negative I, 1. I, negative 1, negative 1i, or negative I, 1. What's I to the 9th going to be?
Negative 1.
What's
1i.
1i. So the pattern repeats by 4s. The pattern repeats by 4s. So this here will keep repeating over and over and over again. Okay, so it goes I, negative 1, negative 1i, 1. I, negative 1, negative 1i, 1. So this is what repeats. I, negative 1, negative I, 1. So now we're going to use that in a little bit. So let's look at this one. Negative 5i times 3i. What do you think you're going to do there? What would logic say that you do?
15,
Negative 15 what? Negative 15 I squared, because you're taking I times I. And you're correct. So basically you take negative 5 times 3 and then I times I. What is I squared equivalent to? Negative 1. So I have negative 15 times negative 1, which is, and that is your answer. All you're going to be doing is simplifying numbers. Now I to the 31st. Okay, so did you write down those ones that I told you? Remember the order. What was the order? I, negative 1, negative I, and 1. So this is the easy way. Okay, let's just count. So this would be 1, 2, 3, 4, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So what does I to the 31st equal? Negative I. Now there's another way. You can sit there and say, well, I know that these are multiples of 4. 4, 8, 16, 20. So I know that the multiple of 4 that will be here is 32, which is what some of you might be thinking. And you could say, oh, well, 31 is 1 less than 32, which means it's going to have to be here with the negative I. And that would be an option as well. But I think that's probably easier just to count. I mean, it's just as fast than to try and reason it out. Okay, here we go.
Square roots.
You know what? These are not that bad. I'm going to warn you. Very first thing you need to do, no, you can't cancel the negatives. If you cancel the negatives, it's going to throw your answer off. So what we need to do is we need to take root 20i times root 12i. Now you can multiply them. So what is 20? And you know, actually I probably wouldn't multiply them yet. You know what I would do? Let's leave them like this. And you'll see why. Remember, in order for us to simplify, we need to break things down. Well, now I've already got a 20 and a 12 to start with. So let's break 20 down. If I break 20 down, 5 and 4. And break 4 down, I get 2 and 2. Now let's break 12 down. So actually, I saved myself a step. Okay, so break 12 down, I get 2 and 6, and 2 and 3. So let's take pairs out. Take a pair of 2's out here. What else can you take out? A pair of 2's, good. So really,
That's
how much?
What I meant.
How much have I taken out? 4. What's left inside the square root? 15. And then look at this. What does that equal? What does I squared equal? Negative 1. So really, negative 4 root 15. So that I squared goes right at the very front. So that makes it a negative 1. Whenever you have an I squared, that means it's a negative. Okay, I think I've got another one here. Let's see. Oh, guess not. Okay. This one, okay, it's like a ton of different ideas. They're all dealing with complex numbers, though, today. X squared plus 64 equals 0. Now, up until today, how could you have solved that? You could have solved that if the plus sign would have been a minus, difference of squares. So now the question is, well, we don't have that. So what we're going to do is I'm going to subtract 64. And I end up getting x squared to equal negative 64. How do you undo a square? Square root. So here I get x equals square root of negative 64. And up until this point, you were like, well, I can't do that. Well, now you can. Because what does that negative mean? I. So it really means like root 64i. But what do you know about root 64? It's a perfect square and it equals 8. Now, one of the things I want you to think back to is I want you to think back to when we did the x squared minus 64. When I did x squared minus 64 and I solved that, that meant x plus 8 times x minus 8, right? And how many answers would I get here? I got how many here? 2. And what were those 2? Positive and negative 8. And remember how I showed you how you could do the plus or minus? Okay, same thing goes here. Whenever you take a square root, and this is something to file away for memory, whenever you take the square root of a number, as we did here, you must attach the positive and negative, and you will get 2 solutions. So don't ever forget that. Whenever you take the square root, you must take both the positive and the negative. With that in mind, I want you to go ahead and complete this one for me. Very first step you're going to want to do, subtract 100 and then divide by 4. Good. All right, so very first thing, a lot of you got to this step right here. X squared equals negative 25. To undo a square, remember we have to take the square root. Now whenever you take the square root, you always have to take the positive and the negative. So here I get x equals plus or minus root 25i. The I comes from the negative. When you go ahead and take the square root, you end up getting plus or minus 5i. Now believe it or not, and I wasn't going to show you this with the factoring, if you had something like this, you could solve it the exact same way we just got done solving it. If you had something like that, if you didn't want to factor and do plus or minus, you could just add 9 to both sides, and you end up getting x squared equals 9. And then what do? Square root, and what's the important thing to remember? Plus or minus, so you get x to equal plus or minus 3. So you get the same thing with that. So if you don't like necessarily to factor with the squares, you can do that and get the same answer as well. Because this is not a negative 9. It's a positive 9. That's a negative 25. All right, the next thing we're going to talk about is what's a complex number. And this is where we get to when we talked about pure imaginary numbers. A complex number is a number that can be written in the form a plus bi. A number that can be written in the form a plus bi. So if you're writing this down, you could just put complex number a plus bi. And that would be the same thing. A, notice, is in blue. We call A the real part. Okay, we call bi the imaginary part. We call it the imaginary part because it's got an I. That's it. So you have your real part and you have your imaginary part. So quick question. Is that a complex number? Yes or no?
Yeah.
Okay, what's the real part? 5. What's the imaginary part? Negative 2i. Okay. Is that a complex number? Real part? Imaginary part? Is that a complex number?
No.
What's the real part? What's the imaginary part?
So anything is a complex number?
Pretty much anything can be classified as a complex number because it could be written in the form. Okay, so anyway, just a little tidbit. I want you to look at this problem. You probably don't even, I don't know, if you want to write them down, that's fine. It's going to take you longer to write them down than it is to give us the answer. If you look at that, I want somebody to tell me what you think the answer is. Take a stab in the dark, okay?
7 minus 3i.
Perfect, that's exactly right. That's all you do. If you haven't figured out, you add corresponding parts. 5 and 2 gives you 7. Negative 7i and 4i gives you 3i. That's it. Gives you actually negative 3i. That's all you have to do on that problem. The next one. What should you do first? Distribute the negative. Thanks. Good. You need to distribute that because otherwise you will lose it. Change the subtraction to addition. So then with that in mind, what do I get? 1 minus 2i. All right, so far so good? Okay, look at this one. Find the values of x and y that make that true. Okay, so what's my real part over here in that problem? My real part is 3x minus 5. What's my real part over here on this side? 7. Yep. Okay, what's my imaginary part over here? Y minus 3. What's my imaginary part over here? 6. So really, what we're saying is that 3x minus 5 equals 7. Somebody else tell me what we're saying. Perfect. All you're going to do is use basic equations here. If I solve the blue, what do you do first? Add 5. So you get 3x to equal 12, and then x equals 4. What do you get for the pink? No. Okay. So all you have to do is set up 2 equations and solve them. Not too bad. It looks way, way worse than it is. Fairly straightforward problem. We got a few more. Few more. Okay, do you think you could handle that? Let's just set up the equations. We don't need to solve them. What's the real part on the left here? 5x plus 1. What's the real part over here? 2x minus 2. So really, 5x plus 1 equals 2x minus 2. So you could solve this one. That's a basic equation. Not too bad. Imaginary part over here. 3 plus 2i, y minus 6. So once again, you can solve them even when the variables are on both sides. Okay, very last thing, and believe it, I'm not lying, this is the very last thing today. Complex conjugates. Basically, we've talked about conjugates. Maybe not called them conjugates. But conjugates, if you notice, first terms are the same, last terms are the same, sign between them is different. First terms are the same. Last terms are the same. Signs between are different. So an example of a complex conjugate, 2 plus 3i and 2 minus 3i. First terms are the same, last terms are the same, signs are different. So what does that look familiar to? X plus a number, x minus a number from the difference of 2 squares. So now, what we're going to have is we're going to have to simplify the following. 2i over 3 plus 6i. You can't have that. Okay, you can't have i's in the denominator. Like you can't have square roots. So what I'm going to do here is I'm going to multiply by the conjugate. What's the conjugate going to be in this problem? 3 plus 6i is the original one. What's the conjugate going to be? 3 minus 6i. Okay? First terms are the same, last terms are the same, signs between them are different. So to simplify that, what I'm going to do is distribute the 2i. What do I get on the top? 12i squared. Good. We'll come back and take care of that in a little bit. On the bottom, the neat thing about conjugates is that they save you some time. With conjugates, the middle terms drop out, so you don't have to FOIL this whole thing out. All I'm going to have to do is multiply the first and the last. So what does the last give me? 36, negative 36, I squared. Now, the thing you need to watch, whenever you've got an I squared, what does that mean? So, this means negative 1. This means negative 1. And see, that was our whole goal, was to get rid of that I in the denominator. You can't have it, it's bad. So here, I end up having 6i minus negative 12, which is 6i plus 12. On the bottom, what am I going to get? Which is? 45. Last thing in this problem. What do you notice about 6, 12, and 45? They're all divisible by 3. 3 goes into 6i, how much? 2i. 3 goes into 12. 3 goes into 45. 15. And there you go. Okay. I think we might call it good for today. I had one more. Let's not even worry about that. Let's go to your assignment on page 250 real quick. I need to look at this in the book for you. So, on page 250, we're going to change, okay? What I need you to do is I need you to do 18 through 53. Okay, so we're going to get rid of that 56. Now, a little tidbit about this. Since we've got some people gone tomorrow, I'm going to cut you a break. This is actually due Monday. Tomorrow, for those of you that are here, I will answer any questions that you have. Okay, but 18 through 53, and I'm even going to cut back more. I'm going to let you do the evens. Okay, so it'll actually be 18 through 52, the evens. So that is your assignment due on Monday. 18 through 53. Well, 53 is not even, so it'd be 52. So.